Can everyone hear me? Yeah, okay, good. Hello everyone, my name is Juanita, and I'm gonna be talking about the UC open source repository browser. And this is a recipe, so we'll cook together. So a little bit about me. From Colombia, I finished my undergrad in math, but before doing my PhD, I was actually a Spider developer, which is an IDE for Python, open source. That's how I got involved with the open source world. I'm currently a PhD candidate at UCSC, and I work with the OSPO at my university. And I do a lot of other things, community related. I'm the community lead for the Scientific Python project, which hopes to coordinate a little bit of the work that's going on Scientific Python ecosystem. And I'm also the communications chair for the SciPy conference, which, by the way, is next month. So talk to me about it if you're interested. So a little bit of background. Last year, UCSC, OSPO, along with other 5 universities, got a grant from the Sloan Foundation to build a UC network in order to promote sustainability and best practices in open source within academic institutions. And the work that I'm going to be talking about today is actually part of this initiative from the UC network. So why are we cooking this? UCRB is, we're hoping, an open source tool mapping and classifying UC open source projects. Huge disclaimer, this is a work in progress. So a lot of things that are going on are still improving, are still changing, but I'm going to be talking about the work that we've already accomplished. So why does this matter? We're hoping that this project is going to help researchers, students, and institutions to connect with projects within the universities, the academic institutions. And yeah, hopefully this will encourage funding and collaboration among open source development. And we are also hoping that this will go beyond UC. Right now, we are just building this for the University of California system, but we're hoping to be sort of like an inspiration for other universities in order to improve the open source project discovery. So what's on the menu for today? The main dish is the UC ORB database. So the first part of this talk is going to be focused on building this database that we're going to use for the browser. So that involves the data collection, data classification, and some insights on the open source picture within the UC California system. And then the last part of the talk, which is actually smaller, it's going to talk about the actual showcase, which is the website that we're building for showcasing some of the projects that we have found through this discovery phase. So for the data collection, we need a couple of things. Some of them are the campus keywords. So in order to discover, for example, repositories that are affiliated with the University of California, Santa Cruz, we're going to use the name, the acronym, the domain, and some alternative names. Like, for example, UC Santa Cruz is another way that people know our university by. The repository attributes, so these are things that we're going to look in the repositories in GitHub with our search. And then the last thing is the GitHub REST API. In this case, we're going to use a search/repositories endpoint, which is going to provide us with all the list of repositories that match these queries. So the first step for this is, of course, to build the search queries. So what I did was basically try to combine the campus words with the repository attributes one by one. So the query, for example, for the alternate name would be like UC Santa Cruz in description. So that searches for all the repositories that have UC Santa Cruz in the description. And then I also added email queries specifically looking for the domain of the university in the email repository attribute. The second thing is, of course, using GitHub search endpoint to find the repositories using these queries. And then this, the GitHub's API provides a very easy way to just have an output JSON file. But what I actually did was I created a database with this because one of the things that I realized I wanted to do was modify this data and add more data and be able to kind of play around with it in an easier way. So creating a database was very important for the continuation of this. Of course, we wanted to collect as much data as possible from each of the universities, especially because one of the problems that we're trying to solve is like affiliation. We want to make sure that we find only universities that are affiliated with the repository, with the universities. So extra metadata also helps. One of the things that I was also interested in was like the community practices, like open source practices. So I collected a lot of extra information that doesn't come by default, like the README, the code of conduct, the contributing guide, security policy, all of these little things that are like indicators of open source practices within the projects. And then all the repository contributors' information and the repository organization's information. And disclaimer, not all of the repositories are owned by organizations. Some of them are owned by users. So this is only kind of available when the repository itself is owned by an organization in GitHub. And then the result of this is a relational database, where we can just kind of match repositories with contributors and organizations, and we can have all this information in order to feed our like information on whether a university, repository is affiliated or not with the university. So this is the output of what we got. This is a lot of information, but I'm going to focus on two things. So this list represents like the total number of repositories that we found per each of the 10 universities of California. In total, we were able to find more than 52,000 repositories. And one of the things that I thought was interesting is that in total, there's only about 4,800 organizations, which means that a lot of them are actually owned by users. And this, of course, makes the problem of associating them with the universities harder. So for the data affiliation, the first thing I want to do is convince you why we need this, why all the 52,000 repositories that we found do not like necessarily belong to the university. And so the first example is if you write collection of computer science courses in GitHub, there is at least 257 repositories. And you would not imagine how many of them have actually like any of the 10 universities from the California system. So a lot of these repositories say University of California, Santa Cruz, University of California, San Diego, whatever, all of those universities. But they're not actually being developed at the university. They're just compilation of resources that are related to the university. And this is like a lot of noise. And this is one very tiny example of a lot of compilations of resources. There is collection of, I don't know, machine learning tools, collection of art courses, things like that. And then the second thing is, did you know that there is 2 universities around the world that have the exact same acronym that UCSC and that are not UCSC? So there's a university in Italy and a university in Sri Lanka that have the same exact acronym. So of course, our queries are going to like pool all of these repositories, but they're not associated to UCSC because they have the same acronyms as other universities. So this problem is hard. So the first thing that I had to do in order to figure out how to determine whether a repository is actually affiliated or not with a university was to come up with a definition of like what does it mean to be affiliated, right? And this was like very iteratively. I went and I looked manually into some of the repositories that I found, and this was like something that was built sort of, yeah, I don't know, intuitively. So this definition covers like 5 main things regarding affiliation. The first is like research group affiliation, so things that have been developed by research groups at the university. Contributor affiliation means not necessarily is owned by the university, but there's contributors that are part of the university that are submitting pull requests or commits into other repositories. Institutional development. So I found a lot of repositories that are, for example, built by the library at the university or the open source program office at the university. Official sponsorship or ownership. And this one, I included it because there are some repositories that are a little bit tricky to interpret, but they actually have in the README very clear, like, this is owned by UCSC, or this is sponsored by UCSC, or UCSD, or any of the universities. And the last one was one of the ones that I was not sure if I should include, because it's like educational resources that are produced by the university, like courses in edX, Coursera, all of these things. And of course, there's a bunch of repositories of students that are like enrolled in these courses. And then, like, I guess it's kind of tricky to decide whether we want to have them in our database or not. For now, we want them, and I guess that it's better to just kind of collect all the data and then figure out how to filter out. So for the affiliation problem, I actually tried the 3 different methods. The first one was the one that I actually was completely sure it was going to work, and it failed completely, and was assigning scores to repositories based on the type of keyword matching that they had on the repositories based on the university keywords. So I went and I found all the keyword matches in all the metadata fields of the repositories, and depending on where the keyword was, I decided a score, right? So for example, things like if you find the domain of the university in the website of the organization, that is clear ownership from the university, so that's one probability. This is an example of a table that I used to compute some of these scores. And I gotta tell you that this failed very, very badly. And the reason that this actually failed is because one of the things that I realized is that context in which the name of the university happens in the repository metadata actually matters. So it doesn't matter if a repository has University of California, San Diego 10 times. If it doesn't say owned by or this is, I don't know, sponsored by the University of California, San Diego, you can't really be sure of the actual relationship with the university. So because of that, I came up with this method that takes into account the context in which these keyword matches appear. So text embeddings, if you're not familiar with this, is just kind of a model that will turn your text into a matrix. And then with that matrix, you have an abstract interpretation of the text. So what I did was I took some of the metadata that I thought was important for the repositories. So in this case, the homepage, the README, the description, owner, and then other organization details like the URL, the email, the name, the description, the company, and then other information from the top 2 contributors, because I didn't want to make the text too long, so I couldn't actually take into account all the contributors. And then I put that into a big text. I shoved that into an embedding model, and I got an embedding matrix. And with that embedding matrix, I actually use traditional machine learning models in order to compute predicted probabilities. So because I use supervised learning, one of the things that I actually had to do was manually labeling repositories so that I could actually get a ground truth in order to train my models. And this, I guess that's kind of the downside of this method, is that it requires a lot of manual work. But the fact that you're using text embeddings is, it's a great thing for considering the context in which the words actually appear within the university, the repository metadata. So because I realized that labeling 200 repositories per the 10 universities was not very feasible with one person, I decided to try something else. So of course, large language models have proven to be very powerful on interpreting text data. So what I did is I pretty much used the same metadata that I used for the previous method, and I provided the definition that I came up with what is affiliation from a repository to a university, and then I provided the university information. So with those 3 things, I built a prompt that pretty much just asks the LLM to provide a prediction on how likely does it think that it's associated or not with the university. And if you're not familiar with RSC curves, they're pretty much graphs that show you how good are your models on distinguishing between the positive and the negative class. So it's not really a measure of accuracy, because accuracy is actually determined by a threshold. But in here, we can actually see some behavior of the 4 models in this case, because I used 2 of the LLMs. And there's a couple of things that are very clear. The method that I described at first was very bad. That's a scroll-based classifier. It's really, really close to the diagonal, which means that it's pretty much random. So not a good method. But the other 3 things that I tried, we can see that LLMs are not necessarily better than other approaches. In UCSB, for example, if you see the curve is actually like higher a little bit for the embeddings. So for the embeddings, I used actually support vector machines. So that's why the title of the line is support vector machines. And the other thing that we can see here is that the results are not actually consistent per all the data sets. So San Diego has actually much worse results. So the data set actually impacts the way that your models are able or not to predict your classes. And with this, I just want to conclude again that this is a hard problem, that it's even hard for LLMs and for machine learning. So in the end, I ended up using one of the large language models, like GPT-4o, which is the one that got the best results, in order to predict all the like repository affiliation for the 10 universities. And this is what we got. Again, lots of data, but let's take a look at these three numbers. The first one is less than 50% of the repositories are actually affiliated. So from those 52,000 repositories that we collected, not even half of them are actually affiliated. This is not 100% accurate, but I think this is a good picture of like what the data set that we collected looks like. And for some universities like UC Irvine and UC Merced, there is actually a very, very low percentage of projects that are actually affiliated with the university. My educated guess will be that it's because their acronyms are probably more common and they probably have more conflicting like acronyms with other things that are completely unrelated with the university. But I would probably have to look more detailed into the data to see why exactly is that difference between those two universities and the rest ones. So now I'm going to show you some insights on things that we found out with the data that we collected. So this is data that it's been computed only on those repositories that we have predicted to be affiliated with the university. So as you can see, in UCSB, there's around 3,000. In UCSC, there's like 2,500, and UCSD has 2,700. One of the things that I think is very interesting is that there's no license for a lot of the projects. That doesn't mean that they're not doing things right. I think that just kind of reflects that there's a lot of different types of things that people put in GitHub. Not all of them are meant to be open source. There's a lot of like class assignments, course materials, and like small student projects, or even just repositories where someone just puts the code there because they want to save it somewhere. But it's not necessarily meant to be open source. And I think that percentage of projects without a license talks more about that differentiation between the types of projects than about the fact that people are not using a license. And then the other type of data that I looked more closely into was this sort of community/open source practices, which is one of the things that you can actually track on GitHub. Like there's a lot of community practices that you're not able to measure through GitHub, so these ones are the ones that I thought would be useful to talk about how are people doing open source within universities. And as you can see, most of the projects have a description and a README, but then once you go onto like other community practices, the percentage reduces considerably. So contributing guide, PR templates, issue templates, and code of conduct are things that there is like less than 1% of the projects. So of like the 3,000 projects, less than 1% are actually doing any of these things. And for me, this is one of the most interesting findings. The security policy is all the way in the end with less than 1%, 0.2% actually, funny enough, the same percentage for all three universities. And I think this is very interesting because it kind of gives us a step forward, like a way to move forward. And I guess one of the clear things that we can do about this is like, how do we help projects increase those bars, right? Not all of the projects need to get all the way up, right? As I said, there's a lot of projects that are not necessarily meant to be open source. But I do think that there is, of course, a clear path for improvement for a lot of these projects. Also, I only presented the results for these three universities, but of course, there's data for all of them, so yeah. And if you want to find that data, I actually wrote a paper about this. It's an archive, so you can actually look into it. There's like more details about like the data classification, the performance on the models, some of the trade-offs of the costs, because of course using like OpenAI, it's not free, and yeah, so there's a lot of other information there that you can find regarding this. So now, for my second part of the talk, I want to talk about the UCORB showcase. So the goal of the showcase is actually to help connect open source projects across the system, and also with external like stakeholders. One of the things that we really want to help projects do is get more funding, and I think having a showcase that will like represent all the great work that they're doing, it's going to be very positively impactful for that. So this is very different than the original data set that we collected. This is actually a manually created set of projects, and we're hoping that they're going to be actively maintained. And this showcase is going to provide searching and filtering of all of these projects that are displayed in the showcase. And we want it to be community-driven. So one of the things that we're hoping is we will put up like a small set of projects, like an initial set of projects, and then we're hoping that people can come to us and be like, I want to add my project, I want to showcase my project. They can probably open a PR or fill a form, or we're still trying to figure out some of the details. And this showcase part of the project is actually being done by Google Summer Code mentee. So I'm like during the summer, I'm mentoring this person. His name is Param, and he's been working on building this website for the showcase projects. So in order to actually find the data for the showcase, one of the things that I did was specifically filter projects by the URL and email containing the university domain. And again, this is because it is very clear the affiliation of a project when the organization that owns them in GitHub has, for example, a website or an email address that has the university domain. I also did some filtering, trying to determine like whether the project is being actively maintained or not. So there is one of the data that I collected for in the initial scrape was when was the last push to a project, and then I filtered. I think I got like if projects haven't been pushed in like 3 years, then I didn't take them into account for these first set of projects. And then one of the things that we really wanted to make sure was that projects were okay with us putting their information on our website. Not because it's private, because all of this information is actually being collected from GitHub, so it's completely public. But we want to make sure that they're okay with us just kind of showing their work in the website and making sure that it's also being actively maintained. We are currently also asking the projects for additional information, which we think will be useful to put in the website. Some of that is like the funders, who are the funders for the projects. Some of the projects have that information in their READMEs, but that's not as easy to find. And then the other thing is contact information. Because the goal of this showcase is to help connect people, I think that having a contact information is like very important so that people know like, oh, I'm interested in this tool or in collaborating or whatever, then having a contact information for that. And also making sure that people are okay with us putting the contact information in the website. And then the last thing is the topic area, which is we want to provide a way for people to filter projects by topic areas. And I think this is kind of like in the future, we are hoping to develop an automatic way to detect these topic areas. But in the meantime, this is something that we're asking projects to provide. So spoiler alert, I'm going to show you how this project is going. So I'm going to go to our like preliminary demo of how our showcase is going right now. So this is how it looks. We have in like the main website shows like these little cards of the projects that have the name, the owner, the description, and then it has something like information like the language and the license. And they have, of course, the university that owns them. Other information that we're displaying, for example, is the number of stars. And we might include other engagement indicators for these. And then this has, of course, a search, so you can probably search, I don't know, computer, and you would find anything like related to these. And then there's filters here that, is it big enough? Hopefully it is. But if not, you'll see it eventually. You can filter by university, so you can just apply some of these filters, and then filter by language, and then, for example, filter by license. The other thing we have is the development team. So one of the things that we've realized is that a lot of the work comes from the same teams. So instead of having, I don't know, 50 repositories from 50 different teams, we actually have 50 repositories from 10 teams. So I think it's really cool to see what are the actual teams that are doing open source within all the universities. Oh, no. OK, well. So that's the spoiler on how our showcase is going. Again, this is manually curated data. So most of the, I guess most of the hard work on this is contacting the projects manually, like sending them emails, and also figuring out if they're affiliated. Beyond just organizations that are owners of projects in GitHub, we're hoping to get other projects that are owned by specific users, but that, the affiliation determination part of that is way harder. So what's next? So after doing all of this amount of work, I have a lot of ideas of what I want to do. I really want to enhance the data collection process. GitHub's API has a rate limit of 1,000 results per query. So right now, I have 16 queries, so the total amount of repositories that I could potentially get for universities is 16,000. But there's a lot more there. So figuring out how to overcome some of those rate limits, like maybe doing more modular queries, filtering by date, some of those things might be helpful for that. And also expanding to other platforms. We are very aware that people not only keep their projects in GitHub, but GitLab and other version control systems are used around. And refining the data classification is also one of the things that we want to work on. As we saw, the model accuracy is not perfect. It didn't work that well for San Diego, which is very intriguing. And I think that trying other advanced techniques, like, for example, BERT, that it's one of those text encoders, could also improve a little bit the results. The third thing is, because we realize that there's very different things that people are doing in GitHub, having a study on actually type of projects, that would be very useful to be able to distinguish between what is course-based projects versus actual tools that people want to open source. So that's a potential study that we can do. And then the last thing, and this is actually the thing that I'm more interested in, is supporting projects improve those bar graphs, right? So helping projects improve the open source practices. This is something that the OSPO is already figuring out how to do. But I think this study provides an insight on what are things that we can help projects figure out for the future. So I'm hoping to actually help projects to strengthen their community and security practices. And I think the showcase is a good excuse for us to try to target that. So if you are interested in this work, this is a QR code to my archive paper. If by any chance you are in any of the University of California and you are doing open source and you want to be in the showcase, fill the form. And then, of course, reach out to me if you have questions or comments or you're interested in some of these things. That's the website for the UC network, where there's posts about some events that we do and some of the other work that we're doing. And then those are the two repositories related to this work. So the first one, Repo Finder, has all the code for the data collection and the data classification and some of the plots that I showed you. And the second one has the code for the web development that we are working on for the showcase. They're both open sourced under MIT, so if you're interested in contributing, in just using it and testing it, just feel free to jump there, and yeah. And thank you so much, and if I have time, I'll be taking questions. I think I do have some time for questions, so yeah, thank you so much. questions? Yes.
Do you have any sort of preliminary data or things you've looked at in terms of activity? And I'm just kind of curious, like I imagine probably that the top like 5 repositories are super active and then it like drops off pretty quickly, but just kind of curious what that looks like.
I have the data. I haven't looked at it though. But one of the things that you collect in this like initial scrape is like I guess the data for the last push. You can also collect like commits and all of those things. I haven't collected any of that. But I do think that things like engagement indicators are other things that I've been using to like track activity. But I don't have an insight on that. Sorry.
Yeah, no, that makes sense. It would also, if you do end up looking at this later, it'd be very interesting to know how many contributors are internal to the EC network versus like external contributors.
Yeah, there is some work that we're actually thinking about doing it. Like the data set that we have, you can ask a million questions from it, and it's really, really interesting. And one of the things that I'm trying to figure out is what is interesting for people. Like for OSPOs, for example, what is the data that they want to see out of this like huge data set, and what are the questions that we want to ask it? But that's a great point. Thank you. Any other questions? No? OK. Thank you so much. Oh, yes.
I know I should know this answer, but would you...
She's one of the co-authors of my paper, so.
Yeah, I read it really thoroughly. When you showed the graph where it had the pie chart, and then you showed the bar chart. I actually would be interested to know if you took out all the unlicensed projects, then potentially take out all the students. Yeah, just like the one of the pie charts. So if we took out let's just take UCSC as an example. If I take out that 74% and only do the analysis on the next, the rest of the whatever 25-ish% that's left there, have you looked at whether those numbers go up in the other chart, like the readme file? Yeah, the community analytics part. Does it look better in this chart?
So.
Did I just give you something else to do?
So I actually haven't done that, but my intuition is that the picture is going to look very similar, because if you see the bottom like community metrics that you can see there are actually very small. So even if you reduce the data set, it's still going to be small. It might look like a little bit bigger in comparison, but. But in reality, it's still very small. And as you can see, there's way more projects that do have description and README. So it might happen that if you take only the licensed ones, then you would get 100% of projects that have description and README, which I think is good. But for the other particular metrics, I don't think the picture is going to change that much. Any last questions? No? OK. Thank you so much. And if you're interested, go read my paper.